Alright, so we're looking at number 27 now. So we've got PbNO32 plus AlBr3. And again, we're going to figure out what goes with what. So we know that the Pb will join the Br and the Al will join with the NO3. So let's take a look at what these look like so we can figure out exactly what's going to go with what. So PbNO32 looks like this, Pb of 2 NO3s, and Al looks like this with 3 Brs. Now remember that we're just going to take one of everything over to the other side. So we've got lead, we've got nitrate, we've got aluminum, we've got bromide. So those are the things that are going over. Looking at the charges, we've got negative and negative here. That's going to be -2. That's going to be +2 overall. So that's going to be +2 there. And looking at this one, we've got negative, negative, negative. So that's -3. That means that this is going to be +3. So the aluminum is +3. So the charges go like this. We've got Pb will be 2+, and that's going to join with Br negative. Remember, just one of everything over to the other side here. And Al 3+, and NO3 negative. Alright, so that's how we figure out what the charges are on each of these species. Now we're going to have to put them all together. Alright, so now I'm going to go ahead and write these out. So Pb2+ and Br-, that's going to be PbBr2, and then Al3+ and NO3-, we're going to need 3 NO3s to balance out the charge on the aluminum. So here I needed 2 Br negatives to balance out this one. Here I needed 3 NO3- to balance out the 3+ on that. If I look at the solubility chart, I'll see that lead bromide is going to be the solid. And over here, these are all going to be aqueous, of course. Alright, so now I'm going to go ahead and balance this out. I've got 1 lead and 1 lead over here, 2 nitrates, 3 nitrates. The best way to balance this is to look for a common denominator here. It would be like 1/2 plus 1/3. That would be 6. So this would be 6 here that I need to find. So I'll put a 3 in front of here. That'll give me 6 NO3s. And I put a 2 in front of here, and that'll give me 6 NO3s. So that'll balance out. Now I've got 3 leads, so I put a 3 in front of here. And that's 2 aluminum, so I put a 2 in front of here. That gives me 6 bromines, and that gives me 6 bromines. So everything balances out. Alright, so that's for part A. Now I'm going to have to do part B, and that means I'm going to have to go ahead and draw these pictures out here. And that'll be Pb and 2 NO3s. And there's going to be 3 of those. Alright, so 3 sets of PbNO32 charges. I can get them from up here. So we've got 2+, we've got 2+, we've got 2+, and we've got negative, 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 negative. We've got AlBr3, and we've got 2 of those, so we've got Al and 3 Brs. And they are each going to have a -1 charge on the Brs and a 3+ charge on the aluminum. Looking over here, we've got the 3 PbBr2 solid, which isn't going to split up into ions because it's a solid. And we're going to have 2 AlNO3 3s. Alright, so looking at the charges on those, we've got 3+ on the aluminum, and we've got got -1 on the nitrates. And now we're going to go ahead and see how this works out with the number of leads. We've got 3 Pb2 pluses, and then I just count up 1, 2, 3 of those. I've got 6 nitrates there. And now I've got 2 Al3 pluses. And I've got 6 Br negatives. And now we've got 3 PbBr2 solid. And now we've got 2 Al3 plus and then 6 NO3 negatives. Alright, so that would be for part B. That would be the full ionic equation right there. What I'm going to do is just go ahead and delete this, and I'll copy this for the next part. And this would be for part C now. And what we're going to do is we're going to do the net ionic equation. And I'm going to chop out anything that's exactly the same on both sides. And we're just going to end up with the reaction that forms a solid. So we've got 6 nitrates, that'll cancel. And we've got 2 Al3 plus and 2 Al3 plus, that'll cancel. And we're left with 3 Pb2 plus 6 Br minus gives 3 PbBr2 solid. So that's one way of expressing it. The other way we could express is just Pb2 plus 2 Br minus gives PbBr2 solid. Either way is okay, that one. Alright, so that's the final net ionic equation for number 27.